Hi there, you're welcome back to my channel. I always wanted to be able to implement something that would ease a computational human stress and problem. In this tutorial, I'm going to be walking you through the data structure that SPaICTHub created, and it's called SPaICTHub. That's the name of the class. The question is, what is SPaICTHub? Let me close this. SPaICTHub is a data structure that contains a list of objects that can be used to queue request body, response data, and later consumed at the UI end. Our motivation in implementing this data structure: there must be a data structure that should be flexible to accept items from any direction, and this item should be accessible at any point in time from any direction. Also, when removing each item or element from this data structure, it should not alter user experience, in the sense that when popping item, it would follow the order at which the items are being added to it. We would want that to happen. Curiosity was instigated by the queue data structure. This class called SPaICTHub implements the queue with some steps forward. This data structure allows insertion from both ends and within the element of the list. At the front, if argument called position is supplied at the point of insertion, we have the following. To instantiate the object of this class, we use the SPaICTHub, as we can see it here. That's to instantiate an object. To insert into the list, that is the queue data structure with position argument equals to 0. Then this is the example. Is SPaICTHub.push, then element and position. Okay, let me give a syntax to that. We say the name of the object we instantiated. Push means to put item, and position could be left empty or supplied. So example is what we now have here. So example is what we have here. Or you can equally do this by saying the name of the object we've created here dot push the item and the position 0. Also, this append the item. SPaICTHub data structure has a method called putWithin. This method accepts two arguments, namely items to be inserted and position argument. This tells where to insert the item. Syntax: the object name, that's SPaICTHub.pushWithin, supply the item and the position. For example, the SPaICTHub.pushWithin, the name of the item we are pushing, and the position, which is 2, position 2 in the list, given that we have item present in the list already. Note, the above push method would append the supplied items to the front of the list. That is, we are referring to the first one, the push method. For the end of the list, don't supply position parameter. That is, you can just leave it like that without supplying either 0 or not. In addition, we implement the reset method. This resets all the SPaICTHub properties. For instance, let me zoom this out. Okay. In addition, we implement the reset method. This resets all the SPaICTHub properties. For instance, the SPaICTHub.reset, or it takes an argument called homogeneous, which is equals to false. This above reset method takes an optional parameter, optional argument. Optional argument that is homogeneous. That this, when supplied with the value of true, makes sure that all items in the list are the same. Okay, SPaICTHub.reset homogeneous is equals to false. The above reset method takes an optional argument that is homogeneous. This, when supplied with the value of true, makes sure that all items in the list are the same. SPaICTHub's elements are the same data type. Therefore, SPaICTHub data type could be either heterogeneous or homogeneous data structure. Author Sunday P. Afolabi. Date June 25th, 2024. System information Mark M1 here. Programming language used to implement this data structure, Python programming language. Location Jos North, Plateau State, Nigeria. Projects privacy. This is an open source project. Therefore, you can contribute to this project via GitHub. Step 1. Fork the project and create a new instance of this project. Step 2. Clone the project locally. Step 3. Implement your thought that is in consonant with this project concept. Step 4. Push to your remote repository. Step 5. Make APIs to the main project. In this stead, means this particular project you forked from. Copyright 2024. All rights reserved. So let's go into the class SPaICTHub. Instantiating SPaICTHub class. We use init method which take into one, of course, self-referring to itself, and it takes one parameter called homogeneous equals to false. It's an optional parameter. Then inside the instantiated class, we have property, and this init, it helps us to initialize class properties. Here we have 4 class properties. We have the list that keep track of all the items added to the data structure, Spark data structure. Then we have self.index is an array as well. This help keep the track of item for deletion. Then we have position, pos, which means position equals to none. When both sides of the list receive item, whether both sides within or, and you want to delete item as they came in, its value are set to be none or 0. So it's used to track where item is being added, its position. So by default, it is set to none or homogeneous. So it says to be homogeneous, that is the value coming from here. When supplied, the value changes. So it takes Boolean value, either true or false. But now, what we have in this stead now, by default it is false, meaning that the homogeneous is set to false. Any item of data type can enter. String, integer, Boolean, they can be synced together in this list. But when homogeneous is set to true, or integer or true, no mixed up data type. So this will strictly make all the items entered into the list to be what? The same data type. This class has a method called isEmpty. This helps check if the list, the queue list is empty. This check for emptiness. Time complexity is equals to constant time to check that. Okay, so it returns true if the list is equals to 0, else false. The next method the class has is called push. Push enables us to add item to the list or SPaICTHub, the queue data structure. So it takes two parameters, one out of which is optional parameter, and while the other one is the item to be added to the list. This method allows insertion at the front and at the end of the list. The time complexity is constant time. If the homogeneous is true, that is, we want all the items to have the same data type, and it is true, it comes into this block. Let me scroll up that you may see. So when the homogeneous is true, it means all the items should be the same value type. And if false, they should come here and have any type of value or data type. Now, let's look at it when homogeneous is true. We check for the type. If type of the item is equals to integer, or type of the item is equals to float, we come in here. So if it is not equals to integer or float, it comes into the other block of else. Then it traces a type error. The list must be homogeneous. Continue with the what? Integer values. So when a user have entered at first an integer, knowing that the homogeneous has been set to true, and you enter an integer value, if what you enter later is not integer non-float, it will throw this error. Else, it comes into this block of if when it is true. Then check, is position none? If position is none, therefore this maintain its value, the post maintain its value to be none. Self.append, we append this to the index. Don't forget, it keeps the track of the index. Then self.list.append item, then we append the item into our list, and we append that the position is not specified also to the index. So here we have else. Prevent randomness. To prevent randomness, we check if position is equals to 0. Therefore, we set the index to what? To is 0. Unlike when it is not specified, when it is none. Now, if it is 0, it appends the value 0 to the index list. Then, update the position of that item added. And that position is 0. So, we also insert the item in the position of 0, meaning at the front of the list. For instance, let me show you. This, let's assume we have 1, 2, 3, and so on and so forth. And you want to append, you want to insert another item. Then the position is set to be 0, and you set the item, let's say 6 or 6. So this method, having supplied the position to be 0, it takes this 6 and inserts it at the front of 1. That is 6, 1, 2, 3. This is what the result you'll get. Okay? But for the first one we looked at, when the position is not supplied. When the position is not supplied, the 6 is added to the front. Should we say the front now? This should be front and back, right? Okay, to the back, to the end of the list. So this is what we are going to get. Let me comment that. So that is the explanations that we're going to see it while demonstrating the value. Now, if it is not homogeneous, that is, the value you want to supply is heterogeneous, you didn't supply it, you didn't set the homogeneous to true at the initial state, then it comes to this block, to this S block. Then we check for the position as well. If the position is none, then we are inserting to the what? To the end of the list. And else, if the position is set to be 0, we are inserting else. If the position is set to any value, then it comes into here. We now equally check again to prevent randomness. We check again if position is 0. If position is 0, this means we have to equally append the value as we did here to the front of the list. Okay, good. Now we now check else raise date type error. Current position must be 0. Okay, current position must be 0. So that is that. Let's proceed. Now to pop. Pop means to delete item from the list. Now this method remove item at the front or end of the list. The time complexity is still what? Constant time. So we're making sure that this algorithm or this data type is efficient in use, and we look at people deploying this into the application. Try it. So if sep.index is -1 is none, that is when the index, now we are looking at the index, we say it helps us to take the track. When we want to delete item, it helps us in deletion. So we are checking if the last item in the index list, that is, let's go up. This index list we declare here, we instantiated here rather. Can you see here is an array. We are checking if we want to delete now, if the item at the last is none, therefore sep.list.pop. So we are removing the item from the list. We are removing from the back. Okay. Now else if the item at the back is equals to 0, we are removing from the front of the list. Can you see? We are removing from the first item of the list. This helps us to remove from the, let me comment it, this removes the item at the end of the list. Then this help remove item. This remove item at the front, the beginning of the list. Okay, so that is it. Now else if it is not the back neither the front, then it will be within the list. So item to be removed, now we say item is equals to list dot index. When it is not the back neither the front, e check for the index, the last item of the index. Then this help to check the value, because that particular, since it is not supply 0, none, empty position, it means an object is added to that. So e check for the value of that object. If that value is what, if it will save the value of that item, then we are removing, we say dot remove item. We are removing the item from the list. So e search for that value in the list and remove it. Then we remove the item from the index so as not to take the track again. Okay, let's move to the next method. The next method is pick. This method returns the item at the top of the list. The time complexity is still constant time. So big O1, that's constant time. If set.pour is none, return item dot the last item, the pick item. Then else return the item at the front if the position is not known. Okay, now here is what that makes SPaICTHub different from the queue data structure. Put within is a new method that SPaICTHub deployed. So it takes two arguments or parameters. The first parameter is the value to be added to the list, while index is what, optional parameter. So it is set to none. And no, this method return none value. Okay, so if index is none, we want to raise a type error. Please enter an index. So it is very important to what? To enter index to insert item at any point randomly within the list, having known that the list has element already. So this one helps us to position anywhere in the list. Okay, so we check for the list length. If the list length is less than -1 is less than index, let's assume you want to insert into an empty list. This one won't be possible because we have checked it already. So let's assume you enter, let's say you say SPaICTHub dot put within, you now put the items 5, 1, 2 rather. 2 means index 2, meaning you must you should have an element that are more than that inside the list. But however, you want to insert value at the position 2. This is going to throw an error, so it's not possible. So this is going to throw an error. Okay, So that is what we are checking. That's the exception we are checking there. So type error, the index you entered is greater than the list length. Can you see that now? So else, if it is not greater than, if all these two have been met, the two conditions has been passed, then you come here to check for the homogeneous of that element in the list. If you set the homogeneous to be true, then it comes in here to check, is it an integer or float? If it is not integer nor float, it traces the value type error. The list must be homogeneous. Continue with the integer value or float, however, as the case may be. Then, if it is true, if it is either this or this, then we want to append it. So we are appending the objects, the index of the object, and also the item itself. Okay? So then we insert it into the position we want it to be. The position, the index of the item, and the item itself in the list. So else, if it is not homogeneous, then we set it at the last or at the end of the list, that is append item. So we append it, we keep the track of the position of that item and the item itself, and also we insert it into the list. Let's go further. Search. We can equally search. Search time complexity is linear time, that is big O n, big O of n. Okay, so we check for the length of the list. If it is 0, we will return type error that no item in the list. No item in the list. Then this should be value type, or let's rate a value type. Value error type. Okay, value no item in the list. So here we check for another condition. If target is none, that is, if you did not supply the value you want to search for in the list, then we raise the value type as well. Value type as well. So supply item to search for. So if these two are met, then we return, we search, we return, we say return true if target is found in list. That's why the big O notation n, big of n, comes from. So it's look through linearly into this item list. Then if not found, return false. Also, we equally can find item. So this is implemented in SPaICTHub as well. It's a method, a new method in SPaICTHub also. We can find item with its index. So we say target is equals to 0. So it's equally a big of O, big O of n, big O of n, time complexity, linear time, okay? Time complexity, big O of n, linear time. So we equally check for the length. If length is equals to 0, then value error. We can search through element or item or list that does not have element in it. Okay, so equally we check if the target is not supplied, but you are using the method find item index, so it will raise this value error as well. So if these two conditions are met, then we go in here to search, to look up for the item. So note that this item now is like an object. Okay, so we enumerate. This is a Python function. We are using this advanced function from Python library. So .list, so he enumerated it into index and the value. So that is why we are unpacking the value. So we have index and item. So we check if item is equals to target, then return what? The index of where it is found. Okay, else return none. When all the item has been enumerated and compared and nothing is found, is the target is not found in it, it returns false. So next we have the size. We can equally, the size also is what is constant time. It return the length of the list of the SPaICTHub list. Okay, we have method called aggregate help us to sum up, most especially the list that are homogeneous in nature, the one of integer or float, they are together. We can aggregate, we can sum everything up. That is, this method sum up all the values in the list. Note, list must be what? Homogeneous. That is, and it return what? Float value. That is it. Can you see it here? It doesn't take any argument, but a method that is used. So we check for the homogeneous. We check if homogeneous is true, then we check for the length. If the length is equals to 0 as well, we raise an error that says list has no element. Then if this one is passed, we check for the other condition, that is, check if the index, the list index 0, the type is not equals to what? Integer. And the type as well of the other one is not equal to float. Either way round, it can be either what? Integer or float. It raise another value, the data type value, that's type error. So it says that the element cannot be added up. Okay, now if these two conditions are met, it comes down to this, and make use of Python method sum. Sum is actually a method in Python library. Okay, so it sums up all the value in the list and return the value to us. Else, if it is not homogeneous, it means it is an heterogeneous value. So this cannot be summed up. You can't sum integer with string on Boolean value. So it raises data type error. This method is not allowed on the heterogeneous list. Okay, so let's move further. We have another method called square. What square does is it returns the square of each element of the list. Most especially, it must be homogeneous. Okay, so it returns back list. So this method I meant to type, this method computes square value of each of the elements in the list. List must be homogeneous and it returns list of square value. So let's look at that. Now, first and foremost, we have to check for that condition. Is it homogeneous? If it is homogeneous throughout, then it goes into this if block section. Then it check is what we have is the list length equals to 0. If it is equals to 0, therefore means that there is no value in the list. Therefore, we can't square any non element list. Okay, so list has no element. So if list has element, then it passes this condition to the next one. It check for the first element. Is the first element an integer or a float? If it is not either the two, it equally raises a type error saying that the element cannot be added up. Okay, so if these two conditions are passed, therefore we can now reiterate true. This is what we called list comprehension. I formerly use map method and this lambda. So I later use what this will do is what the list comprehensions tool will do. So I make use of list comprehension that says you can add for loop inside this angular bracket and do whatsoever operation you want to perform on the operand. Okay, so we have that is x raised power 2 this has 2 asterisk means raised power, so x raised power 2 for x in the list. So it takes one element at a time, and it squares it and save it simultaneously. So meaning that this list comprehension is doing three things at a go. One is looping through the list. Then when the list, it takes that list and square it, perform an operation on it. After squaring it, then it saves it also. So three operations are being performed by the list comprehension. Okay. Two, in this stead, actually in this stead, okay, because sometimes some list comprehension you might not perform operation, you just save the element for x in the list, save the item. But in our stead now, we are performing operation on each operand, and that operand, when the operation is being performed, we are equally saving the value as well. Okay. Else, raise the type error. This method is not allowed on an heterogeneous list. Okay, so let's move further. We have cubic. Cubic method compute cubic value of each of the elements in the list, and this method also return list value, and also it is being performed on the homogeneous type. Okay, so it equally check for that as well. If homogeneous is true, it will check for the value error, that is, the list must not be empty. So we check for that, and going forward, we equally check for the type of the either float or integer. If it is neither float nor integer, it raises a type error, that is, the element cannot be added up, meaning we can't add string value, integer value, float value, and all etc together to give us aggregate. It's not possible. So, or probably cannot be square. Okay, we can do that later. Now, return the list if these two conditions are passed, or they are met. Therefore, we can return the list. You can see now, instead of using comprehension, I use what? I use map method. Then passing this lambda. Lambda is a function without name. So we use that. We pass elements. This method, this map will help us to iterate from this. As it iterates on this, it passes each element, it treats each element at a go. So each element goes like this, passes it like a sequential way. So it passes the element you do what? The function you want to perform on it. Okay, there it stores it in the list as well, as what this list comprehension will do. So else, if it is not heterogeneous, we still raise the what? A typed error value. Okay, moving forward, we have get all items which return list. Okay, this method returns the item at the top of the list. It returns item. It returns all the item. Rather, it returns all the element. It returns all the elements of the list. Okay, so it returns all the elements. Sorry for that. It returns all the elements of the list. So the time complexity is still what? Is still constant. So it returns all the elements of the list. Okay, return all the elements in the list. So moving forward, we have get item. Get item returns an item at a go, or at a time. It returns an item at a time. So from the leaf, okay, so the time complexity is still what? Is still constant time. Big O of 1, constant time. Okay, so what we do, we pass in the index of that item, meaning that for you to get an item at a go, you have to pass in what? The index of that element. There it searches for it. Now, to string, this helps us to set pass the queue. This is another method that this our data type has. You can transform a list data type into set data type. Okay, and it returns that. So this method returns the item at the top of the list. Okay, no. This method returns or converts list uh, data type convert it to a set data type and then returns it. So it converts the list data type to a set data type and then returns it. So how does it happen? You will pass your list. We are using the set method from Python library. So we are passing the list value into it. Then automatically it sends back distinct elements, meaning that if list could contain 1 2 3 1 2 5 whatever, it can contain element like that. But when you pass this list into the set, when that list is passed into the set, let's say let's call this A is equals to this. If A is passed into this set then produce an homogeneous value, or let me say distinct elements of the list. So it sends back 1 2, no element will repeat twice. That's what it means by distinct value. No element is allowed to repeat twice. So we have that. Can you see it now? So should I say compresses the list item of repeated value, okay, into distinct list item of this item appearing once. Okay, so this is the reset method we showed initially. Reset method helps us to reset homogeneous to either false or true. So by default, and also help us to reset all the properties of SPaICTHub class to their normalcy, to their default value. So it reset this back to 0, the list to 0, to this index to empty list, and this one to none again, and reset this one to the default value, which is what? False. Okay, so now having goes through the class of SPaICTHub, let's now the use case, let's use it. The queue class. So this is an object of SPaICTHub class. We call it S. Okay, let's run it. Let's run this class first and see. Good. Now let's run this. Good. So let's move further. We can now use that object. We can use that object to do a lot of things. Let's check for the emptiness. If we've just created it, we just instantiated the object, but let's see if that object has element already. So it say the emptiness is what? True. That is, it's empty. There's nothing in it. So let's look at the O class. You can click on you can use this help to see. It will help you to understand how this class can be used. Okay, so when you click help is a method from Python library. Okay, so then we pass the name of the class, which is what? SPaICTHub. So it help on class SPaICTHub in the module, so main class. So you can see that, you can read through it, you can see what's that our motive again. The motivation is that we want to create a data structure that should be what? Flexible enough for an individual or for you as a programmer to accept item, allow user to supply item from either way, whether from the front, behind, within of the data or data structure. That is the motivation. When removing as well, we should remove it appropriately according how it comes in, not that we just remove any element which can affect or alter the user experience. So we make sure that all that one too is also contained or conserved as well. Now curiosity Curiosity was instigated by the queue data structure, okay? It was instigated by that. The queue structure allows insertion from the front and rear behind, but we don't but in that, well, like, we can equally insert at the middle as well. I mean, I always, as an author of this data structure, I always wanted to be able to implement something that would ease a computational human stress or problem. So that motivated me to build this um, library, this data structure. It instigated me to build this data structure. And for you to see more, you can click on this. Then for you to scroll the element, can you see? You can scroll in. It shows you all the method in here. Can you see? So we have that. Can you see? It shows you that's my name, that's the year it was implemented, and and the information about the system used, the program used, and the location. Then the privacy, it actually all right reserved, and you can equally contribute to that by sending a pull request and send your information to me. Okay, now let's get started. Let's put an item inside this X now. Good. So initially we check for the emptiness of this instantiated class X, right? That shows all true. Now let's check for the emptiness again. Let's check for the emptiness again. After adding this, let's run this. If it is empty, can you see false? That is, there is at least one element in the list, okay, in that object class. So let's check for the size of that. So it's actually what? 1. Okay, let's move further. Let's get all the elements. You can use the method. Let's get that. It gives us back 3. Okay, let's do all that. Let's add a line, another shell here. Let's say x dot push. Let's push another value. Let's push 6, and let's run that. Good. Now let's see. Let's get all again. Let's check for the size again. Let's check for the size. Let's see the size, and we want to check for get all as well. Get all element. Good. Let's check for this as well. Get all element. Let's run it and see. We are going to get the tuple here. So we have 2 elements in the list. Then it gives us all the element, which is 3 and 6. So let's move further. Okay, now we can equally push. You can, like I told you, we have 2 forms or 2 type or elements that can be added into that can be used or added into what? Into SPaICTHub. We have homogeneous and we have heterogeneous. Homogeneous allow us to only add integer value and float value at once without any other another data type. But heterogeneous allow us to have both integer, float, string, and all together. Like this one. And instead, since we did not pass the homogeneous when we are instantiating the class, it assumes it to be what? To be false. So homogeneous means heterozygous in that state. So let's move further. Let's see that. Let's add Sunday to it. Let's add it. Good. And let's get the element. Have we run it? Okay, we've not run that. Let's run it. Good. Now let's get the element. Good. Can you see it now? We have 3, 6, and Sunday as string. Can you see? String value. So now we can s.push. Now this one, we are specifying the position where we want to. Note, the push we have been using since morning, we didn't supply the second argument, the position. So it knows automatically that it should be added at the what? Immediately after each value in the last value in the list. So it added 6 behind 3. It added Sundays behind 6. But now in this state, now we are supplying position to be 0. Let's see what will happen. Good. We have run that. Let's see the position of Peter now. See where it lies. Okay, can you see it now? it pushes it at the front of the list. Can you see this thing now? It's mimicking the same logic of what? The queue in this state. So we can add from both ends. We can add item to the list from both ends, from the front and the back of the list. So moving forward, let's scroll down and see other method also. So let's add the name, this name Afolabi, without passing the argument. Okay, let's add it without passing the position. We have added it. Let's run it. Can you see it now? It added it at the back. Okay, can you see Peter remains this where it's supposed to be, and Afolabi is here. So now let's check the pick. The pick returned the last item, which is what? Afolabi here, the pick of the list. Okay, this is index 0, index 1, index 2, index 3, and index 4. This is the peak of the list. Okay, now let's equally push the name of this channel to the list. Let's add this to the first one, so it takes the position of Peter. Now let's go. Let's see that we've added it. So we've added this. We've added it already. So let's check the peak now. The peak. Now, can you see the peak is the current item that is added to the list? Okay. Now let's now look at the position where it's found. Can you see? It is here. So this is the peak of this new list now, not Afolabi again. Now let's pop. To pop now, it is expected to pop SPaICTHub. Okay. But in the normal, the former data structure we remove from the back, right? So, but this one allows us to remove according to the way each element are being added. Their position, it's removing in order to not alter the user experience. Now let's pop that. Let's see what will happen. Let's run this. Good. Now let's get the item back. Can you see? It removed the last item that just entered, which is this. Okay, not Afolabi, which is at the end of the list. Okay, so scrolling down, let's go. Now let's add another items to the object. So put within help us to add item at any position in the list. So we are setting 5, but note that the length of our list is 3, meaning that we have index 0, 1, and 2. Now we want to add to the what? Index 5, where we don't have 4, we don't have 5 initially. So this is going to throw error. So let's run that. Can you see? It traces what? Type error or index error. We're supposed to do index error. Let me do that. Let's change it now.
Index error, not type error there. So index error for inside the pool method. Okay, inside the pool method, let's see.
We are going to rerun all of those. So let's go back again. It should be index error, not type error here. So we can still work on that. Okay, so please enter an index. No, index error. We can call the index error. Then we can raise here also in out of index error. Good. So let's run that again. So we need to run each element. Okay, let's run this again. Let's run this. Moving forward. Let's move to the next one. Let's run this again. Let's run this as well till we reach where we were. Let's run all again. Let's run all. Good. For the correction we made so as to get so I think this has been run. Yeah, good. 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 We stop at having know that this item has 3 items already. This list has 3 items. This object has 3 items. We are now putting the new item at the position 2 or index 2. So it's search for 1. It count it 1, 2, 3. So 1, 2, 3 is index 0, index 1, and index 2 is was Sunday. Then now it has changed Sunday from Sunday being at index 2 to Sunday being at index 3. Then its new item is inserted in there. Okay, so good. Moving further, we have pop. We can pop. Now let's see which one it's going to remove. I guess you know that we added the new item we added, so it is expected to remove this. Let's see if that will be the one to be removed. Let's run it again. Can you see? Good. This data structure is working perfectly well, so we encourage you to use it. Okay, now we can search. Can you see? We can search elements, okay, by passing the name or the target. So the target here is Afolabi, and note that there is no Afolabi in this object. So let's search for it and see what will happen. So can you see? Search unsuccessful, meaning the item is not found. Let's put proper with not found. Let's use that word, not found. Then this one, let's say found. So let's run it. So Afolabi not found in the list of this object. Okay, so it's working fine. Let's move further. Let's check for Peter and see if that will be found. Okay, I think I should make it a function then, instead of repeating myself here. Okay, I'm not actually repeating myself. Okay, say found, then this will be not found. Okay, let's check for Peter. Oh, Peter too is not found actually, because Sunday is the one there. Let's put Sunday and search. Found, meaning Sunday is in the list. So you can see it now that it's working very well. So the object contains the targets we are searching for, the search time Sunday, so it's found. So let's move further. Okay, now if you are trying to search and you forget to supply what target, it's going to throw an error. That's value error. So it tells you where the error lies. Can you see it? Point at it, and also tells you that this is type of the error that you have committed. Let's see the error. The error is what? Value error. Supply item to search for. Can you see? Good. So now let's print out. We can find by item as well. 3 is found at what? Index 0. Don't forget, 3 is found at index 0. Let's go and look for that. So 3 is at the index 0. Can you see? This is index 0, index 1, and index 2. That's how we count in computer science. Okay, so at index 0, so it helps us to look. Okay, 2 is found at what? Index 0. Let's equally check for the name Sunday. Let's look at where it's found. Let's see. I've not tried that before. Let's see if it will work as well. Good. It equally returned that Sunday is found at index 2. So meaning we have 3 items. The first item is found at index 0. The second item, which is 6, is found at index 1. And the last item, which is Sunday, is found at index 2. Makes it 3. So going forward, let's get all the item again and see it. Can you now see? Can you see? This is 0, this is 1, and this is 2, index 2. So moving forward, let's go. Let's instantiate another object called SPA. SPA. Let's run that SPA and check for homogeneous. Now, the first one we look at is homogeneous is equal to false. Now, let's look at it when it is true. Let's run that. Good. So let's check for the emptiness. So it's empty also. Let's add 4. We are adding 4 to that. Let's try to add, no, this is 3 actually, but it's wrapped in double quote. It has turned into what? String value. So this is not an integer again, so it's going to throw value error. Can you see? Type error rather. So it tells us where the error comes from and jump into the code where we raise the error. So can you see it now? Can you see? It say the list must be homogeneous, that is continue with what? Integer. So it means that it must be integer value, that is, it must be homogeneous. So let's look at it. It's only 4 that we have added that is still inside this object SPA. So let's move further. Let's add 4.6. 4.6 is a float value, right? This point means float point, okay, or decimal point. So in computer science we call it float. So let's run it. Good, it's added. So meaning when you set your class, the object to be homogeneous is equal to true, it expects integer value or float value. So let's do that, because those can be we can apply mathematical operation on them. Okay, good. So now SPA dot get all item, then now we have 2 item in it. So let's equally push 10 at the index 1. This is index 0, index 1. So it's going to be 4, 10, and 4.6, after which we run this. So let's run it. Good. We have added that. Let's go further. Let's go further and get all the elements and see. Can you see now? So it pushes 4.6 to index 2. While it takes the initial position of 4.6, which is index 1, it takes that. The new item takes that. So let's aggregate. We can add it together. Good. 18. So before aggregation, let's add other value. Let's add other value and see that. Let's add another one here. Let me call this one 23. 23. That's the date. My date of birth, 23rd of August. So let me run that. Good. And run it again. Let's see. Can you see? We take the position of 10. Can you see? The 10 is re-added. You know, it has saved that before. So when you run this again, it add it again to number 4. So it first of all add it to index 1. Then when it run the second one, it add this to this. Hope you are getting it. Good. Now let's check the aggregate. Let's add everything up and see the value. So aggregate give us what? 51.6. 51.6. Let's do it manually. 4 plus 23 gives us 27. 27 plus 20 gives us 47. 47 plus 4.6 gives us 51.6. Can you see it now? Aggregate. So let's try and aggregate the former object we declare. That is X. That is heterozygote that we have Sunday and all. Can you see? Okay, let me show you. Let's run that again. Sunday.get all element. So let's see what we have inside that. Can you see? So although we have 2 integer value, but now we have one that is what? String. So is expected. What we expect here is what? Type error. Type error. This method is not allowed on an heterogeneous what? List. So it tells us where the error occurs and help us to take care of that. So let's equally get element. You can see 365. So 8. This one has made it false. Okay. Now let's set another. Let's use another use case. Let's look at another thing we can do with that. SPA underscore DQ. Let's look at that. We are making heterozygous, meaning it should contain any type like what we have here. So let's run this. Get all. We have empty element, empty list. So moving forward, let's check the type of our object. Is the type of the class SPA DQ. Okay, that's the name of the class. So let's run the directory we have in that object. So these are the directory we have in that object. Can you see? This is the directory we have. We can remove the print method, so we can equally get it like in a vertical way. Can you see? We have all of this method in it. We have it. We equally have the method we declare inside it also. You can open up to see all the method. Can you see? So in the SPaICTHub, we have this method. Let's look at those methods we have. Let's count them. We have our home method. This one is the method inherent in class when you declare class, so it's from Python. So we have this one from us: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21. So all the properties of the class and all the method of the class are listed here. Okay, so let's check. Let's make a list item. Can you see? List directory. Okay, this is normal list from Python. We want to see what that contains as well. We want to see. Can you see? You can equally remove this to see. So we are trying to compare our data structure with what we have, the basic object from Python. Can you see? So list has all this method: insert, pop, remove, reverse, and sort, and all. So as time progresses, we are going to be adding more methods to our structure, our data structure. So reset the SPaICTHub. We want to reset it. Let's check for the reset as well, what that does. Now, having added all these values to SPaICTHub, let's reset it. When I click on it, automatically all these value will be removed and set all the values to, let's get again. Can you see? Empty list. So we can push again. Let's push and get again. We are going to see, we are going to have another element 3 there. We push 9, we equally push 5, then we can get all the element, which is 3 9 5 that we just added. Then let's try to aggregate that together. It's going to throw what? Type error. So we can't add string of 5 to 9. Yes, we can't do that. So let's reset. Okay, SPaICTHub.reset. So when the homogeneous is true, it means that the new value to be set, to be supplied, must be true integer value. So let's look at that. Look at that. 5, we have 5. Let's add 7 6 as well. Let's add 7 6, and let's add 23 again. Let's add spark. It won't allow us to do that now. Can you see? Type error. Since that we have what? When we instantiated the object, we say homogeneous is equals to true. So it will not even allow us to add it. Okay, so that is that. So let's get all the elements. So the first one, the last one was not added, which is string. Then we can aggregate this one. Can you see it now? 106. Then we can equally get the element again, the same value. We can square. Now this is the power of square we talked about. When I square it, it is expected to square 5. Square of 5 is 25. Square of 78 is this, and square of 23 is this. This one, can you see now? This computes, it helps solve or ease computational human stress or problem. If you want to be using your calculator or hand now, or writing it and be cracking your brain, you can do it in less than 1 second. Can you see? So this is what computer gives you. So this is the motivation behind us implementing this data structure. So we have this as well. Get all the element in the queue. We know we have not added anything, so we can reset this. We can get all the element again, empty. Here we can push element. We can iterate to add element. So we are adding element of 100 element item inside our SPaICT. So meanwhile, we have set it, we have reset it, and also we make sure that, let's reset that IP again, so that we have SPaICTHub.reset. So let's pass the homogeneous to be true. So let's set that. So let's run it. Let's see what we have in there. Let's say SPaICTHub dot get all items. So let's see, we're going to have empty list now. So we have empty list there. Can you see it? That's an empty list. So we want to add 100 elements in it, looping through. So we have added that. So let's print all the elements. Let me remove this. Let me remove print. Print help us to put it on a row or horizontal, but this one we put it on a list. So let's change it back. Let's make it to be a row so that you can see it. Print. So it added 1 to 100. Can you see it? 1 to 100. Can you see? Can you see? Excluding this 101. It will exclude it. It starts from 1. That's the starting point. Then it ends at n minus 1. So range is a method from Python. So it ends at n minus 1. So it ends at that upper bound. Okay? So good. Let's continue. So let's move further. Let's check the size now. Let's check the size. 100. So the size of SPA is what? 100 elements in it. Okay? So we can equally check for the index 1 or index 2 wherever. Okay? So let's move further. So let's say to set now. To set. Okay, to set. So why are we using to set? Let me give you the use case for that. To set, let's assume we push. After adding 1 to 100, we now add another one which we don't want to do. So we want to get, let's now get the elements. Now let's get the elements. Spa dot get all the elements. Let's run this. Let's use print because we have a long element in that. So let's run that and see what will happen. Can you see we have one here? So if you scroll to the end of this list, we have one again. So one is being repeated. And if we check the size again, the size has grown from 100 to, it has grown from 100 to 101. Let's see that. Let's run that. Can you see? It has grown. Can you see? It has grown from 100 to 101. So now with the use of run set will return what? A list of value, right? So now we expect to have back 100 elements, distinct elements in this list. So if I run it, it gives us 100, which is correct. So let's print it out and see. Let's print that new value out and see. Print set data. Let's see that. Let's print it out and see. Can you see? We have 1 to 100. So it removes any element that appears twice. It returns only one of it. Okay? So aggregate. Let's aggregate the new data now. We have 551 all this one, if you add 1 plus 2 plus 3 to 100, it gives us 5051. So let's look at the maximum too. Maximum or max is the method from Python as well. So it helps us to return the maximum element in the list, which is 100. So the minimum is 1, of course. The minimum is 1. So what again do we have to show us before we wrap it up? Okay, we still reset it back. So we reset it back, the element becomes 0 from 100 element to 0 now. So we are pushing 1 minus 2, we are pushing 5. We want to check for the operator too. Does it equally handle minus value? Let's see that. So it returns negative 2 and 5. So if you add it together, it is expected to have what? 3. This is working perfectly well and is optimized fast. So this is our data structure. You can use it, deploy it in your application, and equally, if there is any question conference that might want me to give more explanations to this data structure created by SPaICTHub, I am available. Reach out to me through this channel or you look up to my profile or email me. Okay, so that is end for now. Please watch out to the new update. But before then, if you have not subscribed, please click on the subscribe button so as to get more updates from SPaICTHub. And to our subscriber who has subscribed in before, we really thank you. Thank you very much. And don't forget to share with your friend, encourage your friend to subscribe, like and comment on this channel. Bye for now.